Hello all, good morning. My name is Omkar Thorat. Today I am delivering a topic of distributed computing. Topic name is message ordering in distributed computing. So today let's understand message ordering in distributed computing. How it important, a message in ordering format, how it works, how it's communicated with each other. Let's discuss on this session. In distributed computing, message ordering refers to the guarantees a system provides about sequence in which messages are delivered to processes across different nodes. It means in distributed computing, message ordering is important because of while sender sending a message to receiver or receiver receive that message, at that time there is a sequence, there is a process receiving that message to receiver side. So in distributed computing, message ordering refers to guarantees a system provided about sequence in which message are delivered to processes across different nodes. So point number 2, this is critical for consistency, correctness and coordination among distributed components. It means while we sending message from sender to receiver, at that time message consistently sent with respect to correctness and coordination with distributed components. So there are three components in the message ordering. First one is client, second one is network and third one is node. So if these three components are not work correctly, then message ordering is failed. So if message order process is failed, what will happen? Let's see in this slide. Why message ordering is matters? Because without proper ordering, system can end up in inconsistent state. It means system can close or that message will not be sent to the receiver side. Second point, make incorrect decisions. Example, wrong leader elected. It means while we sending message from sender to receiver, at that time if we selected receiver correctly, then that message will send to the selected person. Third point, fail to reflect the correct causal relation between actions. It means once message sends to the receiver side or will not receive to receiver side, it failed to reflect the correct causal relationship between action. It means that message will not reflect to the receiver side. Okay, now let's understand FIFO concept. FIFO is, it means first in first out ordering. It means while message sent, for example, sender receive high message to sends to receiver, at that time receiver receive that message high. At the same time sender can send multiple message. So how it works, let's see in this concept. First in first out. So guarantees order per senders. It means while sender is message multiple message at a time. For example, hi, my name is Omkar and I am a professor of CKT college in computer science department. So these three message are sent to receiver but in a queue format. First message will send hi, second message will send as Omkar Thorat, third message is I am a professor of CKT college from computer science department. Likewise, guarantees order percent vendors. It means that message will send sequentially. Does not ensure order among message from different senders. Does not ensure order among message from different senders. Third point is easy to implement using sequence number per senders. It means it will implement sequentially with respect to number per sender. Let's see with example. A sender sends M1 message and M2. M1 message 1 and M2 is nothing but message 2. All receivers get M1 before M2. It means M1 will send, then M2 will send from sender side. But if B sends M3, it might be received before or after M1 and M2. Okay. Now let's see casual ordering. Respect the happens before a relationship from Lamford logical clock. If message M1 caused M2 M1 will delivered first. It means if message M1 calls M2, M1 will delivered first, like P4 method. M1 will send first, then M2 will send, or M1 will deliver, then M2 will send to receiver side. Implementation using vector clock to track casualty. Using vector clock to the track casualty. It means it will track by using vector clock. So let's understand by example. A sender send M1 message, B sees M1 then send M2 message. It means while A send M1 to B side, then B sees that M1 message, then in the form of reply he will send message to from sender from B to A. So M2 is casually dependent on M1. All node must receive M1 before M2. Okay, let's understand third point, total ordering. All processes receive all messages in exactly the same order regardless of sender or casualty. For example, even if A sent M1 message and B sent M2 message at the same time, all node will deliver M1 and M2, or M1 then M1, M2 then M1, but consistently. Consistently it means without disturbing the sequence of that message. Okay, now let's understand fourth point, casual plus total ordering. It's a combination of both casual and total ordering. Respect casual dependencies. Very strong message but more complex and expensive to implement. It means there is a combination of casual and total ordering. So very strong but more complex because it's a combination of casual and total ordering. That's why it's complex and expensive to implement. Now second part of this topic, group communication. Why it important? Let's see in this slide. Why group communication in distributed computing refers to the mechanism and protocols that allow a group of processes or node in a distributed system to communicate and coordinate their actions. It means group communication in distributed computing, it's a mechanism or protocol that allow groups processes or node in distributed system. For example, if we create a group in a WhatsApp, and we have to send one message to all members, group members. So we are not sending one message individually to that group members. We directly send one single message in that group, and that message will send all the member of that group. Likewise, here we mention that definition, or definition tells us group communication distributed system refer to mechanism or protocol that allow group of processes or node in distributed system to communicate and coordinate their actions. It means while sender sends single message to multiple receiver, at that time that message will send single, but uh, it distributed, or that message will send to multiple receivers. It's called as distributed computing in group communication. It is a core concept for ensuring consistency, reliability, and fault tolerance in distributed applications such as databases, cloud services, and collaborative system. If we take one example from database, while we creating a database, at that time we create a single record or multiple record, right? So while we adding that record in the database, there are multiple databases, right? But we choose only one database, right? But in case of for example one entry, we need to add in the multiple database, we can use multiple we can use a different command for multiple records. Means we can insert multiple record in a single database. Clear? Likewise distributed computing in group communication. Now let's understand mode of communication, how we can communicate with each other. So first one is unicast, one to one. It nothing but point to point mode of communication. One to one means one person send message to only one receiver. It means sender send a message and it will receive to receiver side only one way communication. One to one, one person as a sender and receiver side one person will receive that message. Now second is anycast. Anycast means it means one to nearest one of several identical nodes. Identical nodes, it means same nodes, or we can say same server, but it's nearest to the system. Third one is netcast. Netcast, in it means one to many, one at a time. It means sender can send a message to many people, but only one time. If we take an example, we can give a command to soldier, like attention. So if we say attention, all soldiers are make a queue or make a line, and it is in a attention position. Am I right? So one to many means one at a time, or one at a single time. Now multicast, one to many. One to many, it means let's example we have already taken WhatsApp group, right? So one sender send a message to many people, it called as multicast. Broadcast means one to all. One to all, it means there are multiple group, right? So single member can send a message to multiple group. Now types of group communication, so let's understand by brief. One to many, it means single sender, multiple receiver, right? Receiver process message from group, such as group of two types. So there are two types. So first one is closed group versus open group. So only one group members can send message versus non-members can also send message. Peer group versus hierarchical group, it means everybody can interact on group versus one member play role as a coordinator. So it is in easy way or easy communication way, we can see closed group versus open group. It means one group member can send group message versus non-members can also send message for closed group versus open group. Now second one is peer group versus hierarchical group. So everybody can interact on group versus one member play a role as a coordinator. So now advantage of this communication group, these types of communication group, is there is no failure, and disadvantage it is complex because there are multiple members, right? Everybody can interact on groups versus one member play a role. If we say one to one, it is safe and it is easier, but in this group type, one to many, this is a disadvantage. It is very complex to identify who's sent this message or who will receive it. Okay, now let's understand second type, many to one. So multiple sender, one receiver. So many senders send message to selective receiver. For example, here we take example of students and teacher. So many student can can send a can send a message to single teacher or one teacher. So here many senders send message to selective receiver. Receiver can selective or non-selective. So selective, in terms of selective, specific unique sender, the message exchange takes place only if sender sends the message. It means specific person can receive that message. Selective person, we sending that message to selective person. Now non-selective, specific set of sender, and if anyone sends in set sends message to receive, message exchange takes place. It means specific set of senders, and if anyone send in send set of messages to receiver, message exchange takes place. It means for example, uh, teacher can send a message in a group, in a WhatsApp group. There are selective members as well as non-selective members, right? So out of 100, message will sends to only 50% because they are selective. But in non-selective case, we are sending one single message to all students, right? So same non-selective type, specific sense of sender, and if one senders in a set of sends message to receiver, message exchange takes place and uses buffer to control incoming message. Now let's understand third, many to many, multiple senders and multiple receiver. So many senders send message to many receiver, right? Many senders, many receiver, so anyone can send message to anybody. There is no any limitation, there is no any rules and regulation, no any terms and condition. Thank you.